Hello guys, welcome to this Ansys online training session. Today we will see how to solve the Ansys and 2D plate problems on the Ansys workbench. This is my problem statement. I have the plate of 500 mm by 500 mm made up of steel or having the thickness of 5 mm. I am applying the force at this end. I am constraining at this end and I am applying the force at this end. I have drilled one hole of radius 100 mm at the center of this plate. So we will check how the deformation is going on, or what are the forces are coming on this, and where is the stress is generated. So we will start. So go to the Ansys workbench, click on static structural, double click on static structural. So we will get this window. Then here is the first step. Now the first step is to define the material. So to define the material, double click on engineering data. Click on engineering data sources. Then click on general materials. Here you can see all these material. You can pick any one of these material by just clicking on add icon. By default, static structural steel is selected. So and we need that steel only. So I will not select any of the material. I will directly go to the project. Then the next step is to create the geometry. To create the geometry, double click on geometry. At the left below a window, you will see the starting design modeler. This is the design modeler window. We have to draw one sketch. So to draw the sketch, click on XY plane, select look at. Now click on sketching, then select the rectangle. First of all, we have to change the units. So to change the units, go to the units, click on millimeters. Now select the first point, then select the second point. Now I want to define the dimensions to this geometry. So to define the dimensions to the geometry, go to the dimensions, click on general, select this line, then again select this line, enter the dimensions as 500 mm by 500 mm. Now click on fit to screen mode. Now the next step is to draw the hole at the center of this plate. So to draw the hole, select the circle. First draw the circle at anywhere, then click on dimensions, click on horizontal, select the center point of the circle and this edge and drag the window. Then click on vertical, select this center point of the circle and this edge, enter the dimensions as 250 by 250. Now I want to define the radius to the circle. So click on radius, click on the circle, then enter the radius as 100 mm. Now I have completed with my geometry. So again come back to the modeling. Now the next step is to draw a surface. So to generate this surface using this sketch, go to the concept, select the line sketches from surface from sketches. Now select this sketch, click on apply, then click on generate. In this way we have generated our geometry. So I will minimize it. Then the next step is to modeling. So in the model, what we do, we assign the thickness to the geometry. Next we will mesh this model, then we will apply the boundary conditions and the load, and then final step is the solution. So double click on model. It will take some time to load the mechanical. This is the mechanical window. In the model tree, you will see the question mark in front of geometry. So what it is, just open it and click on the surface body. This software asks for the thickness, so I will assign the thickness as this thickness is in meter, so my thickness is 5 mm, so 0.125. So my thickness I have assigned the thickness as 5 mm. Now the next step is to mesh this model. So to go to mesh this model, click on mesh, go to the sizing, enter the element. So in this drop down list, click on off, enter the element size as 5, then right click on mesh, click on generate mesh. So sorry, I have entered the dimension is in meter, so I will convert it into millimeter, mm, kg, newton, second. My thickness is element size is 5, then click on update. So you can see that I get very dense elements. It will increase my solver time, but it will give me accurate results. But I don't want accurate results. I want this is a solution in less time. So I will define the element size as 50 and click on update. It is also bad, so I will reduce it to 10. Now I have got the perfect meshing. So the next step is to assign the boundary conditions to the model. So to assign the boundary conditions to the model, right click on static structural, click on insert, then click on fix support. So and then in the select the edge. I will fix this edge as at one end. Click on OK. Then I will apply the force on this other end. So go to the static structural, right click on it, click on insert, click on force. So select this edge, click on apply. Then double click, then define by is component. So I will apply the force of 10,000 Newton in the positive x directions. In this way we have assigned the boundary conditions and the load to the model. Now the next step is to define the solution type. What kind of solution we want. So on the solution, right click on the solution, click on insert, click on stress, select the one mass stress, then again right click on the solution, click on insert, click on deformation and click on total. Now the next step is to solve this model. So to solve this model, right click on the solution, click on solve. It will take a little time to solve this model. Now you can see that my element stress, so the stress is 160 MPa and the deformation is 0.17 mm. We can see its animation also. So to see the animation, go to the graph and click on play. Similarly, we can see the animation of equivalent stress. Sorry, I have put in the wrong thickness. The thickness is 5 mm. Then again click on solve. Now I have got the perfect results. In this way we have finished our tutorial. If you find any problems, please comment in so that I can help you. Okay, bye.